All right, so today we are going to talk about writing ionic formulas. Okay, so the name ionic formula pretty much always means that the compound is made of ions. Okay, that's why it's called ionic compound or ionic formula. So that means the overall charge of the ionic compound is always zero. So that means if you have a -1 in the compound, you have to have a +1 to cancel that out. If you have a -2, you have to cancel it out with a +2, and so on. So, for example, here, NaCl is made of Na plus and Cl minus. One positive ion, one negative ion. The overall charge is going to be 0 because the plus cancels out the negative. Okay. So every time, so that means every time you have a molecule of sodium chloride, you have to have just one atom of sodium and one atom of chlorine. Okay, if you don't, you won't have a 0 charge, which is impossible. You can't do that. So you have to just have one sodium and one chlorine. Okay. Now, when we are finding the formulas of these ionic compounds, okay, first thing we have to do is write the symbol and charge, okay, for the cation first. And remember, the cation is the positive one, okay? Now, if you have a formula that has a Roman numeral in it, whatever the number of that Roman numeral is, that is the charge of the ion. Okay, so for example, if you have Fe Roman numeral 2, that means you have iron with a +2 charge. Okay, Roman numerals are always going to be the positive one. You'll never have a Roman numeral on the negative ion. If the cation is a polyatomic ion, you put it in parentheses. Okay. So next, you write the symbol and charge for the anion. Okay. The anion always goes second. The positive ion goes first. The negative one goes second. If the anion is a polyatomic ion, put it in parentheses. Okay, the whole thing. Okay, you have to also include the subscript. So if we have a polyatomic ion, for example, SO4 -2, that's a polyatomic ion, and that's sulfate. If you have a sulfate ion, you have to put the whole thing in parentheses. So the S, the O, and the 4. Do not leave out the 4. That is part of the polyatomic ion. Okay. So then you add enough of each ion until the sum of the cation and anion equals 0. Okay. The number of cations is written as a subscript, and then the number of anions is written as a subscript. So we're going to practice a little bit. Okay, we have 3 different names of ionic compounds, and we are going to name them. Okay, so our first one is calcium chloride. So we would look up both of those two parts on the periodic table. The first is calcium, second is chloride. So on the periodic table, we would find that calcium has a symbol of Ca. Now, calcium is in the second column on the periodic table. So that means it's going to have 2 valence electrons and therefore is going to have a +2 charge. Okay. Now, next we have chloride. Now, chloride, first off, its symbol is Cl. It is in the 7th column of the periodic table. So that means it has 7 valence electrons, and it's going to want 8, so it's going to gain 1 valence electron.
All right, so sorry, I had a little bit of technical difficulty, so I had to switch things up a little bit. But the Cl has 7 valence electrons, so that means it is going to it is going to gain 1 electron, and therefore it will be -1. So we'll have a -1 charge. So that means if we put these two ions together right now, so Ca +2 and Cl -1, we will have a total overall charge of +1, which is bad. We don't want a +1 charge. We want a neutral charge. So we can't do that. So to balance out that extra positive charge, what we would have to do is just add another Cl minus 1. So now we have a +2 charge and a -1, -2 charge. So now the +2 and the -2 are going to cancel out, and we're good to go. Now, to actually finalize this and put it into a formula, since we have only one Ca, we would just write Ca. But since we have two Cls, we would write Cl with a 2 subscript, just like that. And that's our final answer, okay? All right, so next one, we have magnesium nitrate. So first we have to find the two different parts. So the first is magnesium. Now, that is an element. So we would look up on the periodic table what its symbol is, and that is Mg, okay? The second is nitrate. Now, since it ends in 8, that tells you that it is a polyatomic ion. So you would look up nitrate on your polyatomic ion chart, and you would find out that it is NO3 -1. Okay. Now, going back to the Mg, we need to figure out the charge of the Mg. Mg is in the second column of the periodic table, which means it has 2 valence electrons, which means it is going to lose those electrons and get a charge of +2. Okay. So now it turns out we kind of have a similar situation as the last one. We just have it with a polyatomic ion now. Okay. We have a +2 charge and a -1 charge. So that means we have to add an extra -1 charge. So we're just going to add another NO3 -1. So now we have +2 and we have -1 -2. Okay, so that balances out. +2 -2 balances out. So since we again just have one Mg, we're just going to write Mg, no subscript. Now, NO3, since we have multiple NO3s, we're going to have to put that NO3 in parentheses. Just like that. Okay. Now notice I kept the 3 inside the parentheses with the N and the O. That's because the polyatomic ion nitrate includes that 3 as the subscript. Okay, the polyatomic ion nitrate is not just the N and the O, it includes the 3. So you have to have that 3 in there with it. Okay, now since we have 2 nitrates, we're going to put the 2 on the outside of the parentheses. And voila, there we have the formula of magnesium nitrate. Now, last one, copper 2 chloride. Okay, so first we have to find the 2 parts, right? So we have copper, that is an element, and we would find out if we looked on the periodic table that the symbol is Cu. Chloride, again, we used chloride earlier, so we already know that it is an element, and its formula is Cl. Okay, perfect. All right, so now we're going to skip copper for right now because that's a little complicated. But for the Cl, we know that the Cl is in the 7th column, which means it has 7 valence electrons, which means it will gain 1 electron and become -1. Now, the copper, since it has this Roman numeral, okay, that means that is its positive charge. So since it's Roman numeral 2, that means it will have a charge of +2, just like that. Okay, so that means since we have +2, -1, we got to do the same thing. We have to add Cl, an extra Cl -1. Now we have a +2 and a -1, -2. And so it's balanced. So we just put them together. Cu, we still only have 1 Cu. Cl, we have 2 Cls. And there we have it. Okay, so just remember, when you are writing out these formulas, you have to make sure the overall charge is negative. If it's not negative, you have to add one or more of the different ions in order to get it to be negative. All right, so we're going to do one last formula. Now, this is a tricky one. So first, we have iron 2 nitride. Okay, so first we got to do iron. Okay, iron is an element. So we would find that its formula is Fe. Okay, and then nitride is just going to be nitrogen. So that's going to be N. Okay, now since iron has the Roman numeral 2 next to it, that means it has a charge of +2. Okay, and nitrogen, since it is in the fifth column, that means it has 5 valence electrons and it's going to gain 3. So it's going to be a -3. Okay. All right. Now, this is why it's a tricky one, because we have a +2 and a -3. Okay. So the easiest thing to do when you're in this situation is whichever charge you have less of, add one of those. Okay. So right now we have a +2, we have a -3. 2 is a smaller number than 3. So we're going to add another Fe. Okay, now that still doesn't help us, right? We have +2, +4, and we have a -3. That's still not even, okay? So since now we have +4 and -3, 3 is a smaller number than 4, so we're going to add another N. So N -3. Okay, cool. So now we have -3, -6. But that still doesn't help us, right? Because over here we have +4. That's still not even. But now if we add one last Fe +2, now we have +2, +4, +6, and we have -3, -6. Now we have +6, -6. Now we're even, okay? So to write out this finalized formula, we have Fe, and there are 1, 2, 3 Fe's, so we're going to do 3. And then we have N, and we have 1, 2 N's, 2, so we do 2 right there. And that is the finalized formula.